All right. Hello, everyone. Welcome to today's live stream event. As always, as every Tuesday, we have exciting guests here who will talk about nice and interesting product topics. My name is Dennis. I'm a senior product management consultant at Product People, and occasionally I also am the host at that live stream. Before we dive into the topics, I just want to say two things. First, that you can ask questions already now if you have them. So basically, you can scan the QR code if you have a phone by your side. If you don't have your phone by your side, just type slido.com and then enter the code that you see there, and you will be able to ask any questions to our guests today. Also, we will have a poll later where we want to get to our audience, and that will be also happening through Slido. So please save slido.com on your browser or on your mobile phone right now. So today's guest is very exciting. So it's Arman. He will talk about the current big wave of products, which are like building agentic AI products. I'm very excited about this topic, as I also had a touch point at one of my clients working on an AI agent. So I'm still also quite learning, and I hope that I will also learn today a lot of things from Arman. But before we start talking about it or handing it over to him, I also want to talk about myself. Again, briefly, I will just keep it short. As I said, I'm a senior product management consultant working at Product People for quite some while, but I was also a product manager before at a mobility startup. And I had a chance to work in different kind of products. But as I said, I also had touch points with AI products. A few words about Product People for the ones that have not joined any of our live streams before. So we are doing two main things. The first one is how we make money. So we are a consultancy, and we are offering interim product management, product ops, and transformation.
Okay, seems like we have a technical issue, but I'm happy to take it from where have we have left off. 1 second. All right, I think we can take it up from here. Just a reminder to anyone and everyone who's watching, you can participate on the poll here to tell us how familiar you are with the concept of agentic AI. We would love, and I think this would help our speaker as well, to know his audience today. The QR is also going to be available for QA at the end of the session, so keep an eye out for that. Arman is going to be here to answer your questions as well regarding his talk and agentic AI. Okay, so from the answers that I'm getting, well, Arman, for your information, 67% of our audience are total newbies and are here to learn about agentic AI. Okay. I have to say I'm including myself in that group as well, so I'm quite eager to hear you out. And a solid 33% have doubled in related projects. So it's a pretty diverse audience that we have today.
Very cool.
Mm-hmm. Okay, so without any further ado, then I'm very happy to introduce our guest speaker today, Dr. Arman, about building agentic AI products. The floor is yours. Let me just.
Excellent, fantastic. Happy to be here. Hello also from my side. So my name is Arman, and I'm very happy to be sharing a few ideas with you today in this context. My journey with AI started off maybe over 15 years ago with an AI PhD. The topic of the PhD was essentially intraday financial markets prediction with a focus on the Forex market based on online news text mining. So there were elements of NLP in it, understanding text, understanding language based on it, trying to predict, whether the market goes up or down, or a particular index goes up or down within a time frame. In this context, a couple of hours later. There were many learnings in this PhD, but from a product standpoint, the primary advantage in that context is that the problem was very nicely formulated. After that, I kind of took that overall curiosity and interest in AI and data and analytics and to multiple fronts. So past 20 years have been 10 years in different corporations, starting with T-Systems and Shell, and then at Zalando, helping build the product analytics group there. And then later on, for the past 3 years or so at Henkel, build a larger group for around personalization with a customer data platform at its center for the many hundreds or a couple thousands of websites and the dozens of e-commerce initiatives that are there. And then the other 10 years of the experience has been as a startup founder and in the startup space with various different startups. In the past year also, I've come out and I've put my focus on a new one called AI, in which the focus is on coaching. It's both for career coaching in the context of data and AI, specifically for product people, data engineers, data scientists, etc., as well as startups, people who are about to start new startups or have startups and I'd like to take them to the next level. And that's called AI. So today, the theme of the conversation is around AI. And what many of you might have heard is that we say AI is the new electricity, right? AI is the new electricity. And the way we have to think about it is that electricity is available. AI is available just like electricity, almost a commodity. And the question is, how do we use AI and how do we create products with AI and around AI? And that's what we want to think about together a little bit today. And in doing so, I'll try to bring a number of different ideas together, but my primary focus always in the context of product, as we all do, is to ensure that our focus is, from what product should I build or can I build to what problem can I solve? And of course, the mastery of this problem space versus the solution space is, the mark of a good product manager. And this is what we're going to exercise together also a little bit. And I'll try to share a few hints and a small framework, which what I'm shaping, which I call the problem sensitivity framework, which helps me in thinking about this. In general, every time we have a sort of a problem space, and if you start from there, then you say, okay, there is this technology, and then you can say, okay, this part of this technology can be useful in that problem space or in that area where things need to be done or some job needs to be done. And every time we create something with technology that is outside that problem space, that might end up being something interesting, but not necessarily useful. And that distinction is, again, something that differentiates a successful product from a not successful one from my perspective. And hence, the question, could also be, okay, like in general, what is value and how value is created? And one simple way of thinking about it is that, value is created through solving a problem, right? So that's also another kind of a mental model. And just on the side note as well, now, if you have a successful product or if you have a successful business, and if it's sustaining, it means we have managed to have a product, it can be a product, can be a service, that can be offered at a price point that is way below the value that it's offering. So there is demand for that product, and its cost is below its price, so that they can have a profit, so that they can kind of generate a margin that can keep the overall initiative running. But just to go back from the product perspective, the problem sensitivity framework, which is sort of my mental model of thinking about problems and products, and it becomes interesting, and I'll give you a few examples also soon, starts always at the very bottom with a need. So I imagine this kind of a pyramid. The very bottom, we have almost like a human need. Human needs are all are timeless. They're technology and solution independent. And then there is a particular context in which that need needs to crystallize itself. And then there is usually a solution for that particular context. And then there is a quality of that solution, which is the quality of then our experience. So if, for instance, if we say, there is a need for communication, right? And the context is while traveling, then there is a solution like a mobile phone, and the experience, bad coverage, the connection might not always be available, and that determines the experience, right? So if we don't have a phone at all, right, we can't have that type of a remote communication. If we do have a phone, but we don't have it in a traveling context, right, then at that moment, so the need for that context starts emerging, and you go towards a particular solution, which could be a mobile phone. And if you have a mobile phone, of course, it becomes about the quality of the experience with that mobile phone in the context of the mobile phone. Of course, then you can also imagine other solutions, which would be then a parallel. But this breaks down and sort of pinpoints where the problem is. And then there is, so essentially there is one vertical axis, which is the what, and that's what we discussed. And then I also imagine another horizontal axis, which is the problem intensity. The problem intensity is how frequently does that problem occur, how urgent it is, what's the cost of inaction. If we don't do anything, how much is this costing us? And what are the existing kind of workarounds? And if there are a number of workarounds, that's also, again, a good sign that it's the right point for us to go in and build a product around things. So that was sort of one pyramid. And then we established in our context around AI, we wonder in this human needs. And one way to look at the human needs is using another pyramid, which is the Maslow's hierarchy of needs. And the Maslow's hierarchy of needs, as many of you might have seen, you have at the very bottom this kind of biological, physiological needs, safety needs, belonging, love, esteem, and then it goes all the way to self-actualization. Now, if someone wants to have like this kind of esteem, then there is this sense of control. In that sense of control, there is also a part of it is related to understanding our context, and in general, cognitive needs, as I've marked it. So when we're working in this space of AI, I would, argue that the underlying need is in that space. And if there was one term to use that could be a good one to describe that particular need that we are after is the word understanding. And then now there is a third pyramid, and these are the three key pyramids that I'm showing today. And it also shows how pyramids help us understand things. And the key element in creating pyramids is also essentially abstraction, which is probably the single sort of most critical, most impactful word in computer science or in general knowledge, in my view. And in this case, if you see, this is called the data, information, knowledge, wisdom pyramid. And it starts at the bottom with data. And then, from data, you see patterns, you go to information. From there, you go to knowledge and to wisdom. And at every level, your depth of understanding about something increases. At the wisdom level, you're in the predictive context. Your understanding is so much that you can kind of predict what happens next into the future. And at every step, going from one level to the next level, what is required is learning, and that is sort of enabled and empowered through intelligence. So that's also something profound to kind of keep in mind when we think about artificial intelligence and intelligence, because that's fundamental to be able to derive products and kind of product ideas, or be able to identify needs and kind of connect them to the overall objectives that we're trying to deliver with products. And then from there, if you sort of focus on that understanding problem space and say, okay, historically, what are the key things that have happened in the past 20 years or so, then you notice that there was like an information access problem, and the internet sort of solved it. And then there was an information availability, and then things like Wikipedia solved that, right? Collected information, structured information. Then there was things like Google that helps us retrieve information. That was an information retrieval problem, or the first sort of iteration of search problems. Now, of course, ChatGPT is kind of helping in that context as well. But what it is doing, it is also helping on top with something which I would then call information digestion problem, which is it allows you to actually analyze and understand the information that has been retrieved. So that could be one way that I propose to kind of think about the overall problem space around the need for understanding. And in that context, of course, that understanding of what intelligence is crucial, that we kind of refer to. And in there is this idea of abstraction, which is very central. Now, if we look at our brain or our mind and how we operate, there is a lot of things there is a lot of data points that we have collected. And these data points, we can kind of, retrieve them at any given time. You can say, well, what's your age? And you can remember a number, or you pull out a number. And then, or it could be a pattern that you pull, but you have that retriever mechanism from your almost like subconscious memory, right? But once you bring it into your conscious memory, then you have a space in which you can kind of reflect on things. There's a number, and then you want to add that number with another number. You hold both numbers in your conscious memory, and you do the calculation, and you have another number. So this distinction between almost this subconscious and the conscious, which then gives rise to a retrieval system and a reflective system, as I call them, is also crucial in this overall understanding of architecture of intelligence. And this is in parallel to what was also mentioned in the book Thinking Fast and Slow by Daniel Kahneman, who won the Nobel Prize in 2002, I think. And in there's two systems described, system 1 and system 2, right? Essentially, your system 1 is this retrieval system, which is quick, and your system 2 is this reflective system, which is slow and conscious. What I then argue is that what LLMs have solved, what large language have solved, is very much this retrieval system. So LLMs are able to kind of, have that kind of an intuitive sense of being able to do pattern recognition or retrieval of data points and information from, a so-called sort of a subconscious memory, let's say in this context. And in order to make a point also around that, how that has come about, it's interesting to think of this new law much like the Moore's law that we used to have, or we still have, but has been empowering all of computing and computer revolution for the past, let's say, 20, 30 years. The neural scaling law is a new law that is saying that the count of the parameters, or many of the other characteristics of a large language model, but let's say the count of the parameters is increasing quite substantially. If you look at some numbers here, for example, 2018, GPT-1 started off with 0.12 billion, way lower than a billion. But if you go all the way to the other end, just in the span of a few years, 2014 GPT-4, it's 1,500 billion. That's 1.5 trillion parameters that can be used. And just to put that in the context of the human brain, if you compare that with the cerebral cortex of the human brain, where most of the cognitive abilities are, that is 16 billion neurons. So from 16 billion to 1,500 billion, 1.5 trillion, that's like 100-fold there, okay? So that means, even from a physical sense, we have created something that is far more, so far already 100 times more, sort of capable on particular dimensions than the human brain in that context. So that's the LLM side of it. So that can then, this powerful machine can enable this kind of a very powerful, retrieval system across different languages, across different domains of knowledge. It's at the same time a doctor and a lawyer and an engineer and a physician, and a physics professor and all that. So that's what the LLMs have enabled. But what we need on top of it is this kind of around it is this kind of a reflective system. And that is what the agentic systems, or this agentic architecture, is enabling. So agentic is essentially, agentic AI is you can think of it as the software that is being wrapped around intelligence. And this software is doing what software does. It allows for creation of these different workflows, or this conscious activities that are workflow-like. The difference is, however, that the decision mechanism, or the decision flow in that control flow, is not necessarily deterministic anymore, because at any given point, based on the things that the LLM returns, certain undeterministic or fuzzy decisions can be made, which were not possible before. And that sort of opens up a whole new category of software. And one could argue that all software that we have could benefit from that new problem space. And as a result of it, most of what we have could be revamped or augmented in a short period of time into the future, maybe 5 to 10 years. And once you do that, then you have these so-called agents. So the agent essentially is a piece of software that is wrapped around this intelligence, and then can use this intelligence intelligently. It can have then access to tools, for example, and a tool could be anything that enables, a capability for that agent that does not necessarily have to come from an LLM. So, for example, a calculator does a perfect job in adding numbers or multiplying numbers. We should not expect an LLM to do that for us. So if we have an agent set up, and the agent, if you ask it, 2 + 2, instead of it asking from the LLM, it recognizes by asking from the LLM that it's an addition, and then it goes to that particular tool. And as a result of it, then you have a system can pull out a calculator or any other tool that we have. It could be a calendar or anything else, or it could be a web search, and call it at the right time, right? That's where an agent starts shaping. And of course, one of the tools that it can call, it could be a code interpreter. So it can then run pieces of code. And that's how the various amazing, types of agents are shaping, that are helping us code and are helping us do all possible activities. And of course, in addition to the tools, another key architectural aspect in an agent is the memory in which there is also a lot of thought as to, what are different types of memory. Then you have short-term, long-term memory. How do you define and structure the memory? But that's also a key aspect. And of course, then also, this whole area of planning and how do you think about breaking tasks down, and then, reflecting on something that is whole, breaking it down, and then from there, having different parts of it acted on again differently. So those are also flows that are happening in an agentic architecture. They're relying upon what an LLM replies, but then you have multiple calls to the LLM for each of these steps, and as a result of it, it's just like you connecting to your kind of subconscious or your intuition for the different parts of a decision, and then putting the different decisions together so that you come up with a holistic answer. And already, if one takes, for example, and this was from a long time ago from Andrew Ng's group, that showed that, a GPT 3.5 compared to a GPT 4 compares better. A 3.5 can compare better in an agentic context. So this was the big argument around, and it's quite apparent as well that you can make something that is a lot more intelligent with a 3.5 wrapped into this agentic architecture than just increasing the capability of the LLM, which then led into, even ChatGPT or OpenAI kind of pivoting or focusing on this new series of models that they have released now, which are sort of agentic first and focused around the agentic activities. So this is a super crucial topic. A lot of activity exists around it, but I think it's going to pretty much touch all software, and that's why we mean what we mean when we say kind of this new wave of products that are coming. And I think some of these understandings will help us kind of navigate that wave, I hope. So hence, this understanding of the problem space is crucial, and this understanding, every time you think about the information problem space, understand this data, information, knowledge, and wisdom. And if in that space you think about what is it that this generative AI capability is doing, then you will kind of notice that at every level, it can be the data, it can be information, knowledge, or wisdom, it is kind of producing and consuming it. It's producing and consuming it. So you kind of can almost start forming two super categories of products or features that are around production and consumption of data, information, or knowledge, or wisdom. And with that, then you can see holistically from another angle that you have, a lot of products that are around, production first. So if you create a blog post or if you create a book, you're in the production space. Consumption, whereas if you read a blog post and you summarize it, you're in the consumption space, right? If you anything that is with regards to the comprehension of large amounts of text is comprehension, and around consumption. If you produce things as production. Now, of course, in a ChatGPT, like, you're kind of doing both of those things, but they can be referred to, in my view, as different feature sets or different perspectives, and different products choose to have different levels of emphasis on each area. And in addition to those two big buckets, we then have this orchestration and layer, because we need a lot of infrastructure and software that allows us to kind of connect different things and create this agentic architecture and call the different services that are needed and orchestrate things effectively and swap between the different LLMs. And all of that infrastructure is also a completely different category of products, which is primarily the infrastructure products that are needed for this agentic AI era and time. Yeah. So hence, when we kind of step back a little bit and think about agentic architecture as a whole, all of the things that we discuss is within that agentic architecture. So inside the software agentic architecture, all of those things that we discussed are in there. So that's one big aspect of things that have become technologically possible with LLMs. But it doesn't stop there, because we also are getting this new interface, this new user interface, which we call the conversational user interface. You can converse with the machine. And this whole new user interface allows us to do things which were not possible in a normal, graphical user interface. In a graphical user interface, even if you kind of consider your experience of booking a airplane or anything else, or shopping, you're essentially limited in the in the form of drop downs and radio buttons and filters. You have very little flexibility. You have to go through various lists. If you want to search for something, you have to kind of give your criteria one by one and find the intersection. Very time-consuming type of an activity. That's why every time we want to book something or buy something, it takes hours at times. All of that has a chance to now, from an experiential standpoint, to be bettered, right? Removed, solved. And that becomes possible through that conversational user interface. And I argue also then on the other side, also from machine to machine or from application to application on the API layer, also we're going to have breakthroughs, because the APIs don't need to be also so restrictive and so strict. They can also be fuzzy to an extent. So it's it's possible to create an interface with different systems without necessarily being like fully written for those applications. So even in that space, there's going to be new interface capabilities, and all of that gives great promise and ability for a whole new generation of software that is already spreading at a rapid pace. And on that human machine interface, also one other point from a product standpoint or experience standpoint to reflect on is interesting. If you see machine on the one side and human on the other side, if you think keyboard is, it's much closer to the machine. If you have mouse, it gets a little bit more closer to us because it's a little bit more natural movement. Multi-touch, or how we use our iPad, was a revolution. Suddenly it allowed all kids, 2-year-old, 3-year-olds, 4-year-olds, and very old people to be able to naturally interact with computers without necessarily having to use any language or learn any language. So that was a breakthrough. And now conversational, it's, I argue, as close as it can get to how we as humans interact and interface with each other and talk to each other and communicate with each other. And there is, of course, this deeper thing which they call the brain-computer interface, which is, for example, Neuralink from Elon Musk. But that's inside the brain. I argue that it's very useful in situations that there's disabilities, for example. But from a normal context perspective, for human experience, this conversational interface, I think, is most optimal. And so that was also a thought around interfacing in the context of agentic architecture in general and the AI applications. And one of the last thoughts I'm going to leave you with is this whole idea of impact of availability of intelligence. So in general, when AI is available as such, as is electricity, and we're using it, a lot of the doing of activities is going to be possible to be automated. So in that context, then we go from the how to the what. So the problem is less how do I get this done to what is the right thing for me to do. And that shift is important for product managers, for entrepreneurs, for anyone who is thinking about, where the need is. The need is for jobs, the need is for people to be able to decide what is the title or topic or the story for a book, blog post, software. Not necessarily how to do it, but what exactly it is all about. And that comes from a point of view. And that point of view is your reason for your choice for a title or a topic. That usually comes from a domain specialization. So deep familiarity with a domain gives you a point of view or a sort of a formed opinion in that space. And that's one side of things. And the other side of things is what I call intelligence affinity. Of course, the more you use AI, the more you understand its physics and mechanics and how it works and what it can do, what cannot do. It also enables you to be able to use it at the right place. And the last chapter is also all of this, of course, from a product standpoint. We have to have an understanding of cost and the elements that have an impact of cost. And there is three things that in a lot of conversations are getting jumbled up in terms of what those things are. And they're all referred to as AI, but they're very different things. So one is the code generation capabilities. Now we're getting increasingly capable code generation capabilities. For example, the leading thing there is Cursor AI. I'm sure many of you have tried it, which is an editor that has essentially your LLM integrated in it. And as you're coding, it not only monitors your code base, it generates your code base. You can navigate structure and do your development much faster through that code generation that is natively inside your editor. That's a very powerful agentic application, that Cursor AI. There's of course other things like Replit, and they also, because once you have the application, you can also have one-click deployment and just have the application that is live and in production. In that context, you just say in natural language what you want, and it gets built and it's deployed. So there's a lot of different things, platforms that allow for this. Replit is of course also one of them. That's code generation. But then there is this other wave that's been maturing for many years, but this has reached a very nice point. It doesn't have anything to do with AI from one side of it, which is the overall no code, low code, right? Leading thing there is, for example, Bubble. You can do amazing drag and drop activities that effectively work. We've always had sort of visual programming. 20 years ago, we had them as well. But now, in terms of structure, things are reaching a point that are very useful. And they're not necessarily only oriented around people who don't know how to do software engineering, but I argue that it's very important to enable software engineers with low-code, no-code types of activities, so people can understand architecture, but they don't have to be bothered too much with solving bugs and doing kind of boilerplate code. So that no-code, low-code activity is also another thing that helps us quickly create agents and many other things. Now, of course, good no-code, low-code platforms now can also ride the wave of agentic and usage of AI and LLMs, and they're best structured to help also generate applications. And in that context, then you have a no-code, low-code and generation of code or applications in the same bundle. But that distinction is still necessary. And lastly, there is a whole group of things that allow you to create workflow automation, things like Make.com, N8N, and Zapier. And these ones have been there, but now they're very prominent because in order to create that conscious workflow, in order to create that agentic workflow, you need to be able to call different LLMs at different points in your overall workflow. And of course, one of the easiest way to quickly do that is using these applications. Hence, if you are creating an agentic application, you are using these applications as well, or these platforms as well, but they're not necessarily AI related, but they allow you to create that kind of an agentic AI wrapping around things as need be. So that might also be beneficial. So to wrap up, the job of a product manager, much like an entrepreneur, is identifying problem, design, build solution with people, process, and tech in a sort of self-sustaining type of a fashion. And in that journey, we always have to keep our sight on three things. as we're starting off, we have to make sure that the problem is valid. And if you have that problem market fit, it means we know a problem on its own, independent of the solution, the problem is valid. We know that we have value and enough value if we create that, if we solve that problem. Then we come up with a solution for that problem that you call that problem solution fit. So you have the solution should work. So that becomes the problem solution fit if you have a solution that works actually for that problem. Now, if your solution or your product is accepted into the market and people pay for it, then you have product market fit. I think that distinction is also crucial for startups and might be a good thing to close with. So I hope some of the ideas I shared might help us not feel like the eating machine of Charlie Chaplin. This is something, for one reason or another, that always comes to my mind when I look at the latest craze around AI. And with that, we can transition to questions. That's me on LinkedIn. Happy to be connected.
So I'm back, and also apologies. My Wi-Fi dropped midway. Kind of funny because we talk about the future right now about AI, but my Wi-Fi is not capable of staying alive. But I was still able to listen to everything you said. Thank you very much. We will move on to the questions in 1 to 2 minutes. I will just briefly share again my screen here. So basically, we are collecting all the questions on Slido. However, if you don't have access to Slido for any case, you can also submit your questions on LinkedIn. I already saw that one viewer already asked a question. Thank you very much. So feel free to send the questions on LinkedIn or on Slido. While we are collecting the questions right now, again, a few words about product people. So I said it briefly in the beginning, that we are an interim product management consultancy, and we are offering product management, also product leadership on an interim basis. Like can be between 3 to 12 months. It always depends on the needs of the customer. We also can offer program management or product operations, so we also have experience in there. But we also can help in shifting an organization that is very sales driven and drive it to more like product-led growth. Here you can see a few selected B2C clients that we work with. This is just a glimpse. We work with many, many more. And this is a B2B client list that we work with. So you can also see that we have a wide variety of industries and experiences all over Europe. Some statistics about product people, because I think this is very worth mentioning, is that we already help more than 300 cross-functional teams and support more than 70 plus clients. We have in-house 42 product leaders and managers. This is very important to note because everyone who's working at product people is not a freelancer. We are employed by product people, and we are really like helping your company out when you need the help. And last but not least, also some proud numbers is that 62% of our team members are women and 66% are in leadership positions. So we really care about diversity in all sorts. So also our team members are not only from Europe, but also outside of Europe. So we are really looking into expanding our teams. Now we will move to the Q&A. You still have time while I will coordinate the questions and shoot them towards Arman. Let's see. So we got a lot of questions already. Let me see. I will start with the one question I saw on LinkedIn, Arman. So the question was, how do you feel about the balance of tech debt and using no-code, low-code?
So in general, using any framework, especially low-code, no-code, avoids, creation of technical debt. Because technical debt comes from when you do things sort of inappropriately or with a sort of a short-sighted type of a manner, or you need to have something temporarily and then you will never find the time to clean it up. And if you work in context of a framework and if you adhere to the standards and the rules of that framework or the building blocks of that framework. As a result, you naturally have less technical debt. We lost your.
Sorry. Okay, thank you very much. I think we have a lot of technical issues today because for some reason I get the information that on LinkedIn they don't see my screen. So apologies about that if you don't see the screen. But if you have any questions, please send them towards LinkedIn or here as you can. Okay, now you should be able to see it. Thank you very much. All right. So the next question would be, how can we ensure transparency in autonomous AI decision making?
So I wish I could kind of understand better what the question is meant. Of course, in general, there is a topic of sort of transparency or in general explainability in AI. But sort of the general question, how can we ensure there is transparency in autonomous AI in decision making? If the question is asking, how can we understand or explain what decisions are made and why, then that's, that is dependent on the guardrails that we put around our problem framing and how we kind of decide how much of a playroom we give our decision-making framework. I think as long as we have a framework that is defined clearly and we know what the boundaries are, then we should be able to also kind of feel comfortable with the decisions that are made.
Okay, thank you very much. Yeah, I think in general also transparency, it's just an assumption from my side, but I think, for example, if an AI agent takes a decision, how can we make sure that the user of the AI agent knows how the decision was made? So I think like a chain of thought or something could also help, I assume.
Exactly.
Yeah.
Exactly.
Another question is examples. So are there any examples of KPIs to track success with using or deploying agentic AI?
So I think KPIs are always problem specific. So depending on the problem that we are solving, we define a North Star KPI the same way that we've done before. The fact that our system is now more flexible and can do that we can tackle more problems, I don't think necessarily has to impact how we define KPIs from a user experience standpoint. So a user needs to get the answer to a particular thing. Either they get the answer or not. If they get it, it's success. If they're confused and say that they don't find their way, then they're not. And then from there, we can kind of define a success from an experiential standpoint, KPI, I would say.
Okay, thank you. And adding on that a bit, is there like one mistake that you commonly see when somebody wants to build an agentic AI that you would like to share with us?
I think these distinction of these topics is important. I think it's important both from a technical standpoint and from a philosophical standpoint. Understanding from a technical standpoint, understanding what is code generation, how does it contrast against low code, no code, how does it contrast against automation workflows? This is important in overall architecture. And then that kind of a subconscious, conscious, or the role of the LLM in the context of the agentic architecture, and understanding what agentic architecture is as a whole is something that I think is emerging. I feel people are using the word agents quite casually. Agents are essentially almost like apps, right? Applications with new capabilities, and we shouldn't keep saying like applications as if applications as a whole is one set of things that have common characteristics, but we have to say an application for this, an application for that, and kind of try to zoom the conversation around that. These are some things that I think will help the conversation to be more effective.
Okay, thank you. Also, a follow-up question here from my side, and I will go back to the audience because I'm curious, is do you think like that in the near future, we all will have our own like agents like we develop and own our own agents. What I mean with this is that I read an article that said that as we move forward, we will have like hyper specialized agents for us ourselves, and like other people like building apps will be out of the race because they will build apps that are not very relevant to me.
I mean, the fact that each of us are already using agents, right? Every time we're using ChatGPT, we're using an agent. Every time we use any other parallel solutions, ChatGPT, if we use Copilot in the Microsoft platform, we're using an agent. Now, if I have to be in a position to be able to create my own agent, then again, that depends on the level of abstraction. Now, of course, for a long time, it was very easy to write 2-3 lines of Python and have a script that does something. I don't know how many people from the total population do that. Now, of course, there might be one particular script that is used and you change a couple of variables and then it's customized for you. In the same context, I think will be applied to the usage of agents.
Okay, thank you very much. There's one question about from a software developer. He wants to know like what kind of skills he should focus on today to stay relevant in the AI generation field.
I think increasingly, as things are evolving at a high speed, being full stack is more and more important. I think one person can do a lot of, can have a lot of impact, can build things. I think that is very powerful. And if you can build something end to end, and you can do it because it's fast, right? If you're using code generation, or you can be the front end and the back end and everything, because you don't have that time limitation that we used to have. And then you have that holistic perspective. And now if you understand agentic architecture as well, it means, how best this piece of software can leverage LLMs and AI, then you're in the best position to deliver, the type of software that is going to be needed pretty much everywhere.
Thank you. And do you have any courses or books that you could recommend us to read and upskill, like besides building our own agents maybe and trying it out? But
I will be putting a AI engineering course together that's not released yet, but there is a lot evolving. I don't have a reference to at the moment, but I can do that in a follow-up.
Okay, sure, no worries. And also, this is also a good call actually to really connect with Arman on LinkedIn to not miss the course that he's developing. But yeah, awesome. There is a follow-up question actually to my very first question that I asked, which is regarding the tech debt. She specified the question a bit more in detail, and she said that she means more AI code like vibe coding. Would that not lead to more like tech debt if like more and more people in the company would use it?
So vibe coding essentially is using something like cursor AI. So if you're using code generation, you're vibe coding essentially, which is an interesting term. And all of us should be vibe coding, right? Because whatever we want to do and we know how to do, we should definitely do automatically. And sometimes we don't know how to do something. It's okay to get suggestions as to how that thing can be done. Now, if you want to accept it blindly and move forward, that depends on the situation. So you have to assess the risk, and you say, okay, like if my input is correct and my output is correct, and what happens in the middle of it, it doesn't matter for me in this context, then fine, as long as you make that judgment. So that's going to be very specific. I think a good software engineer can kind of judge to what extent a piece of code needs to be accepted blindly, as they have been always doing in their various peer reviews and acceptance of code.
I agree, because a lot of like people think always like developers or software engineers are just kind of like code monkeys, but they're actually not. Like we're doing so much more than that, and that's why also I'm a firm believer that AI will not replace any of us. It will just change our jobs in the future. Also for product managers, not only for software engineers. Awesome. There is one more question regarding multi-agents. Someone asks, when does multi-agent make sense? Like, if you have a kind of examples where agents work with each other to solve something.
So one thing that is interesting to realize is that when we say an agent, right, and then this agent has access to other tools. Now, this agent can have access to other agents. This agent is certainly calling various LLMs and getting the output from one and using it as the input for the other, right? So in that context, it's already you can call it multi-agent, multi-LLM type of an environment. Now you can say, now I want to go beyond that. And let's say a common example for it is that you want to do a blog post. Now, a blog post, one agent could write the content, agent could do the SEO review, one agent can do the legal review, one agent can do an overall meta-analysis and put everything together. So that becomes the sort of a multi-agent context in which each agent is specializing in one particular domain, and then you have defined how these agents talk to each other, and then there's different design patterns for that. That then the agents can, for example, have a conversational pattern that they can talk to each other, or they could be sort of a group pattern in which a task is kind of broadcast and a particular agent can picks it up and delivers a result, and then they sort of rotate. Now, how each agent takes turn in carrying out their activity leads to a set of design patterns that I actually have another talk about, which then sort of shows how the various design patterns that are emerging in agentic architecture are shaping up. But that's sort of a talk that's a little bit more targeted at software engineering. That's why I didn't include them today.
Okay, makes sense. Thank you. One more question, and I'm not quite sure if I actually kind of understand it, but maybe we can both figure it out. Is there like a framework or guideline we can use to identify a bad use of agentic AI? I mean, it makes sense, but I mean, saying this makes sense, but kind of, do you have a framework or guideline kind of to figure this out before developing an AI agent that would maybe be bad?
I think in general, any product that we're shaping where we're just shaping something so that it's agentic, but we lose sight of the problem, is going to be probably not a very good use of our time, right? So that's just like before, we always have to start with the problem. Is there a solution? Then solving the problem, that is success. If we don't start with the problem, we start with the solution, because the new technology is shiny, most likely we won't get far.
I agree also with this. Do you have like an idea or like a suggestion on how to, because as product managers, sometimes depending on what kind of company you are, like the CEO is coming and says, please do AI or whatever, because everyone's doing it. How would you kind of like lead this conversation to say, hey, stop, first let's talk about the problem? Do you have also an approach for that?
I think that sensitivity around like what the problem is, and that's why I define this problem sensitivity. And of course, another very good framework is the jobs to be done framework. And then there is, even if you read the book like Mom's Test and Overall Customer Development from Steve Blank, etc., all those conversations, you learn how to conduct a conversation so that you find and validate a problem. And that requires kind of practice to master, but it is possible to be conducted. But it requires some practice, and those books, I think, are quite insightful.
Okay, thank you very much, Arman, for sharing this. The time's up, but I still have 2 more slides that I would like to present. But before presenting the slides, I again want to thank Arman for taking his time here to educate us about agentic AI products. But also, more importantly, this is not over yet. Meaning, if you have any other questions that you didn't have the chance to ask right now, please don't hesitate to reach out to Arman on LinkedIn, and also stay tuned for his course. I think this will be very valuable. And then a few more words about us. As I said, we have also a newsletter, so please scan this code to stay up to date. We're sending a newsletter once a month. And we're also hiring. If you want to join and work with us, please do so. I also saw a message that said, "Are you operating in the US?" From someone from the audience. I think you were asking product people specifically, and the answer is no, not at the moment. And then a very sneak peek for next week. We are continuing with our AI talks. So next week we'll talk about AI first transformation strategy and road mapping. It's a very, very good point as well. And I think it's also a good bridge to what Arman said. And we are looking forward to see you also there. And yeah, that's it from us. Thank you very much, and hope to see you in the next live stream or in real life. Thank you very much.
Thank you.